Sorry, I'm really sorry. So far, I have muted the audio and I have talked. So I'm really very sorry. I'm really very sorry. I have made a mistake here, actually. To do. Really sorry. How many minutes it has taken? Right. Let's start from. I'll start from the beginning. Okay. I'm really sorry. I have muted and talking so far. It's my mistake. So don't worry. I'll explain the things again. Uh, yeah, I have to. Can't I share? Really, I'm sorry. I have muted the mic and talking. Sorry. I'm going to start it again. I'm really very sorry. Okay, let's see what's population. Population is any group of characteristic. I mean, population is any group, those characteristics we learn or we look at in deeper. A population is different from a sample, which is a small portion of the population used to generalize about whole population. Here, I'll talk this with an example, taking with an example. We can say yesterday, new set of students, large number of students entered to our school system. That is where we welcome them warmly in all the school for grade 1. In Sri Lanka, we have more than, the exact number I can't remember, 10,000, maybe 10,200 plus, so like that the number we have. The schools in Sri Lanka. In all the school, if we take and consider the number of students entered to grade 1 yesterday, that's the population, we can say. For an example, right? In that population, we take a group of set of students, a group of students. Let's say the student who entered grade 1 to in 2026 in Kandy district. If we consider them, that is the what we can say, that's the sample. Right? I think yesterday more than 4 lakhs students entered to grade 1. From that, if we take Kandy district and we count the number, take the number, that's the sample. For an example, let's say it's 50,000 students. Example. So, in the sample, there are often lot of diversity. If we take those students, the grade 1 yesterday, the students said who entered to grade 1, we consider them, their height differs. Their weight differ, their medium of instruction differ, their mother tongue differ. So like that, we can find lot of variation or diversity. So, so that is the different variability there, variety is there. So if we are going to consider about their weight, whether they have the proper weight, I mean that they have the graph of the weight below that malnutrition, like that overweight, like that we say normally, the normal weight we find in the graph like that. If we are going to study in the candidate district, regarding the student's weight, then that is the character we are going to study, how it vary among the sample. Right? So here we have in the previous lesson, you have already learned the medium, mean, and I mean medium, mod, mean. Can you remember what is medium? What is medium? Medium, where if we divide exactly 50% the given data set, we group them 50-50 like that. If what is the meaning of mod? How many times it appears, the data, the value, the same value appears in the data series. That is not how many times, which value appears more and more. Here, you see that mean average value. You can read here, no, now? Yeah. Average value of data set. Here you can see a new symbol. This symbol is called as mu. Mu. That means population mean. The average value of the population. Average of the height. In our example, students, average weight. If we consider all the students in Sri Lanka yesterday who entered to the grade 1 and take, if we calculate their weight and by divide it, we calculate their weight and add all the values and divide by the number, then we will get a mean. That mean is called as mu. That is the population mu. Here we take a certain number of students, that is candidate district. The students who entered to grade 1 in 2026, how many? For an example, let's say 50,000. Then if we collect, we calculate all the 50,000 students' weight and we add all them divided by 50,000. Then we will get a value. That value is called as the sample mean. That is X bar. In statistical, we indicate it as X bar. Here X bar, that's why here if we take X, what is X1? Now the value of weight of one students, let's say like that. Like this it goes and you have to divide by here you can see the symbol This is called as sigma. Sigma means the total number of number. Here the total number of weight divided by number of the sample. Right? For example, here see very simple example. Here you are given a data set 1, 4, 4, 6, 10. There are 5 numbers in the data set. The first, sorry, okay. So here there are 5 numbers. Each number's value is different. This is the first number, its value is 1. This is the second number, its value is 4. This is the third number, its value is 4 again. This is the fourth number, its value is 6. This is the fifth number and its value is 10. So, what we have to do to take the x bar, that means sample value, we have to add all these numbers. x1 plus x2 plus x3 plus x4 plus x5 divided by total number. 1, that's what here. Here, the number 1 plus 4 plus 4 plus 6 plus 10 divided by 5. Then we get 25 as total here. Again, we have to divide 25 by 5. Then the mean value of the sample is 5. The data series given here is this one. The mean value is 5. Here again, with another example, we will try to understand the concept. Right? Here see in the data set 1, 2, 3, 4, like that the data set goes. There are 27 numbers. That means sigma F. We count one by one. How many? Sigma F equals to 27. The first number, if we take the number, this is the first number. What's the value? 1. What is the value of the second number? 3. Right? Here the numbers, here 1, the number value 1, here we write how many times it appears in the series. That is the frequency. So 1 comes, how many it appears 6 times in the series. Let's say, let's try to find 1, 2, again 1, 3, 4, 5, 6. That's why we write here 6. Let's take the number 2. How many times the number 2 appears in the data series, given series? Here it appears once, 1 time. This is the second time it appears. This is the first time it appears. This is the second time it appears. So 1, 2. That's 2, 3. Again it appears. Let's say like 1, 2, 3, 4. 4 times it appears. So we write number 4. The number 3 appears in the series 5 times or comes it 5 times. Right? Likewise it goes. That is called the frequency. Here what we have done in this table, we have multiplied F and X. F is multiplied by X. So F means frequency, X means how the value of the number data set. Here we have to multiply. Higher. So 1 multiplied by 6, then it equals to 6. Here 2 is multiplied by 4. Then we get number 8. Value is 8 there. Here we multiply 3 by 5. 3 into 5. 1 into 6 equal to 6. 2 into 4 equals to 8. 3 into like that. 3 into, 3 into 5 equals to 15. 6 into 5 equals to 30. So what we do, we add all these numbers. That means 6 plus 8 plus 15 plus 12 plus 20 plus 30. What's the value? 91. So here we divide 91 by 27. Then the sample mean value 3.37. What is the difference between these and those? Here in this example, this is a small series of numbers. Only it had 5 numbers in the data set. But in the given data set, in the second example, how many? 27 is somewhat large. So here we can directly calculate, we can add and divide, but here it's somewhat difficult. We can make mistakes, so it's easier to, if we tabularize like that, we put it into the table and find the values, and if we divide like this, we can get the correct mean value. That's easy for us. Here, see, another example has given here. Further understanding. Right? Further understanding. There are 25 teachers. Each teacher travels to school every morning in his or her own car. The distribution of the driving time in minutes from home to school is given here. Here you can see a difference. What's that difference? Can you identify? In this data set, as here see 1, 2, 3, 4, 5, 6 like that. Here it has grouped. This data set is not grouped, but here it has grouped. That's the difference. If it is not grouped, we can do it correctly. Here it has grouped. So let's see how to do. So it has already grouped and given to you. Here that means from 0, within 10 minutes, how many teachers come to school? 3 by their car. Between 10 and 20 minutes, 10 teachers comes to the school. That's the meaning of it. 6 teachers come to the school they take to come to the school 20 minutes to 30 minutes. The range is given there. The intervals are there, 20 to 30. Here, 4 teachers takes 30 minutes to 40 minutes to come to the school. Similarly, 2 teachers take 40 minutes to 50 minutes to come to the school. So, these two we can say they are far from the school. Right? So, Here, majority of the student. What is the majority number here? 10. Among here, which is the majority number? 10 teachers they take 10 to 20 minutes to come to school by their own vehicle. So, here we have to find out the mean value. The average of the minute. To that, a table has given here to find out it easily. Not here. Here, see, here there are 3 columns. X number, frequency, and here we F is multiplied F into X, or F is multiplied by X. Here we have another column. Additionally, we have another column here. Look at the second column. This is driving time, that is X. This is the time interval. Class, we call these as class intervals. Driving time has given in class intervals. 10 to 0 to 10, 10 to 20, 20 to 30. They are class, each one is a class interval. How many class intervals are given here? 1, 2, 3, 4, 5. 5 class intervals are given here. And here see, here this column is new to us now. Mid value, it is indicated as mid value. What is the meaning of mid value? Here say mid. How to find out it? Here we have to take this value, the first, 0 plus 10, then it's equals to 10. We have to divide by 2. Then we get 5. Mid value. Mad හරියටම mad value එක. Here, mid value, 10 to 20. Then what we have to do? We have to take 10. Then we have to add 10 and 20. Then we get 30. We have to divide it by 2. Why? There are 2 numbers we have added. So we have to divide it by 2. Then it's 50. Right? The mid value. Here the mid value 25. Here the mid value now you can find it's 35. Here the mid value is here 40 plus 50. That means 90. We have to divide by 2. It's equals to 45. This is the new column we find here. Here you can see number of teachers. If this is, we know this. Number of teachers. This data has given to us. That comes here. This one we find using the given data. This one also given. In the example, it has been given to us. Using this, we find the mid value. Then this one has given already to us. Again, to calculate the mean value, we know we have to multiply frequency into x, f into x, this one. So here it's there. Then here in this year we took the 2 into 4 equals to 8. Likewise, here we now take the mid value. Here it's 5. 5 into 3 equals to 15. Here 15 into 10 equals to 150. Similarly, we do. And the next step, we calculate here see sigma, that means total value of fx. Total value of fx. What we have to find is x bar. What is x bar? It's me. So x bar equals to sigma fx over sigma f. That is 545 over 25. That is then 21.8. That means the sample mean x bar. So there are 25 teachers in the sample. The average time taken by teachers is 21.8 minutes to come to the school. Average time they take to come to the school is 21.8. That's the mean value. See difference here, the simple data set. This is somewhat large, so here we didn't tabulate, we didn't use a table, but we organize them in a table form. Because the data series is somewhat long, right? Here, group data. These are ungrouped data. They are not grouped. But here it has been grouped. So when the data set has grouped, we have to use this method to find the mean. When the data set is not given in group, ungrouped data set, when you get an ungrouped data set, then you have to use this, the format of the table is this. You have to use this type of table and you have to calculate. When the data given is group or given in class intervals, like twice, how you will find the mean? You have to use this type of table, right? Then you can find the mean of the sample easily using the equation. Right? That's what I think you got the idea. Here see group data, mean of group data. See, okay, mean of group data. Another way, there is a shortcut method, it was so known as the shortcut method, or there's another way to find it easily, right? In this method, an approximate mean, it also called as assumed mean. Assumed mean. We assume a number. It can be the mean is taken and preferably near the middle. It will be near the middle, right? Say, and here see, data set has given weight and number of students, right? Yeah, with the example, we look at the equation. Then you can understand it easily. Here see, the weight has given and the number of students have given. This is another method of finding mean value of the sample. Right? Here simple, this is the weight and the number, how many students was 10, 6 plus 4, 10, then 20, 12, 12, 14, 15, 15 students are there. Their weight has given here. Right? The, I mean here, what is the mod 6, no? Frequency 47 comes, I mean, not 6, the highest frequency is 6. So 47 is the mod. 15 students. Here what they say, we use a assumed or assume. We assume this can be the, I mean, preferably near the middle of the 50. 15, if we divide 15 into 2, I mean, what is the middle of the 50? What is the value of the 50? I mean, middle number of the 15, 7 point, if we divide 7.5, that means 708. 7 and 8 between. So, here see, it has given like this. And you come to this one and you can see, here, 49. Here see. Here, like this, no? I mean, wait. This is the way character we study here. 47, 48, 49, 50, 51. This is the middle one. This is the middle one. The weight. We can guess. Even you can take the, I mean, assumed mean as 48 and you can calculate. You can take the 49 as assumed, you assume 49 as the mean and you can use this equation. Even you can take 50 as the assumed, mean and use this calculation to find the equation. You try. In this sum, in the example, I have taken, normally we take the preferably near the middle one. So we take 41, 49. This is the, if we see this in this equation, this is x bar that you know already, that is the mean value. Here A plus sigma FD. What is FD? Now, again, a new number comes. New formula has given to you. Here, see, this is the weight in the table. Here, see, this is the number of students, Fi. Number of students. This is the given. This has given here. Number of students has given you. This, the weight has given you. You have put it into the two columns. And here you take A. This is A. A means the difference. Here D means difference. How to find the difference? X minus XA. What you have taken as the A assumed mean 49. Assumed mean you take 49. Assumed mean. A means assumed mean 49. This is the data given, the value. Here 47. So here you have to, here minus 2 has given here. How 47 minus 49. 47, this data set. 47. This is, the 49 is the assumed mean. So minus 2 comes here. Here, x means here, this one, this value, 48. 48 minus 49, that means A. X minus A, no? Then 49. So, this is the larger number. I mean 48 minus 9. So minus 49. So we get minus rina එක. Right? Here 49 minus 49 here. So we get 0. Here 50. Then this becomes as large. 50 minus 49, 1 plus 1. Here 51 minus 1, 51 minus 41 plus 2. This goes at 0, minus 1, minus 2, 0, 1, 2. Right? But here there is another column. FD. Here we get FX. Here we get FD. We have already found D. Here is F. What we have to do? We have to multiply. 6 into minus 2. 6 into minus 2. So minus 12. Here 4 into minus 1. So you get minus 4. 2 into 0 equals to 0. 2 into 1 equals to 2. 1 into 2 equals to 2. Here, sigma. Sigma means total. Total value of FT. To find out total value, you have to add all these three. Normally in mathematics, we add all the, minus ones together and plus ones together. Here 2 plus 2, 4. Here the value is 4. Here minus 12 plus minus 4. Then, but the value? Minus, but the value? Minus 16. Minus 16. Minus 16 plus 4. Then minus 12. Right? See that this is the equation. A plus sigma FD over sigma F. A කියන්නේ 49 plus sigma FD equals to 12. It comes here. You write 12 here. And FD equals to 15. Then 49 minus 0.8. Then the real mean value is 48.2. Here we assumed 49 as the mean value. Here we use this equation. Right? You don't worry about the equations. All the equations will be given to you. You have to just put the values and find the values. In the tables, you have to write the table and formulate the table and find the values. Right? That's what. This is another example. Here you can see this is another example given. Another example for here same set. Here data has given. This is when you see, look at the data, you can see, you can find whether it is a group data set or a ungrouped data set. Here the data set given to you is a grouped data set, group in class intervals. It has been given. So here grouped. Then you know which equation you have to use. If it is group data set, which equation you should use to find the mean value. If it is not group, then which one you have to use, right? So here, see the weekly wages, their salary in the rupees. So we can say in their, unit, we can, let's say it's Sri Lanka, then we have to put here rupees. Number of workers. How many? The total is fx equals to 20. This is the given data. Here you have written. Then mid value. You have to find the mid value. Now here this is not, here see, this is not the group data. The data only here, not group. Here single value has given here. This is, sorry, here single value. But here it is group. So you have to find the middle value. If it is group, you have to find the middle value. Then you know how to find the middle value. What to do? 300 plus 350. Then 750. You have to divide by 2. Right? Then 325. Here the same. D. Here we have to find D. How to find D? That is the, we should take here. Let assume mean be A. Mean be A, that is equal to 475. 475. We have to deduct here. Deduct X. X means mid value. What is the mid value? 325 minus 475, then minus 150. Here what you do? FD. You have to multiply this one by this one, then you will get minus 3,600. Like similarly, you have to do the calculations. Then you will get a sigma FD here, total value of the FD. This is the equation. X bar equals to A, that is assumed assumed mean value. You think it will be like that, plus sigma FD over sigma F. Here you have found these two. Then you have to substitute. Just to substitute and do the calculation. This is, 400 and here 475 you assume as the mean, but the real mean value is 466.25. This is another way. Right? This is another. Here, this one now you take 475. 475. Here, now we change the assumed number. Here 475 you took as it. Here you assume it is another series. This is another series, isn't it? You see? Another series. Yes, it start with 300 to 350. But here, like we see, there is another example. Here, assume the mid value comes like that because they are odd numbers. 0 plus 99 equals to 99. We divide it by 2, then 49 plus 5, like that. Here 100 plus 199, that means 299. When we divide it by 2, it equals to 459.5. Likewise, okay. Here you have taken 449, this one as the mean value. Then you have to find the difference here. X minus assumed A. So you get like this. Here F D. You multiply, and here what you do, FD. Sigma FD. Again the same equation, you find 503.5. You try to do. Individually, you try to do. Then you will find. Right? You try to do each sum individually. Then you will get a clear idea. Okay? So, deviation. The deviation x minus mu. What is x? What is mu? Population mean and sample mean. Mu means sample population, so not population mu. Then the difference between value x and population mean, that is called the population variance. Here we did know, here we took as the sample, the difference between two. If you take this one, you can see the difference. This one is the mean value. This one is x given data. This is the mean. If we talk about the population, then we have to say it as the population mean. If we talk about sample, then we say sample mean, right? So here, this one minus this one. The difference between value x, the value given to in the data set, we find in value x and population mu, population mean is mu. That's x minus mu. X minus mu means deviation. වෙනස්කම්. Exactly අපි කියනවා මේකයි population මේ sample එකේ mean වෙන්න ඕනේ කියලා. එතකොට ඒක mean එකයි ඒ data set එකේ තියෙන value එකයි අතර තියෙන වෙනස. So population variance means equals to average of the squared deviation. The deviation. This is the deviation. ඒක average of squared. Let's see what is it. Okay, keep it aside. Variance measures how far the value of the data set are from the mean on average. දැන් බලමු මේක උදාහරණයක් එක බලනකොට ලේසි understand කරන්න පුළුවන්. Right? These are the I talked about last time standard deviation. Using as an equation, we can find what is a deviation. Can you remember? I show you some pictures of camels. Okay, this is the sample values. Simple. Here again, I'm with the pictures I'm going to explain. I'm going to explain it again. Standard deviation. Standard deviation is the square root of the mean of the squared deviation from the mean. මෙහෙම කියනකොට මොකක්ද? It seems as difficult, but it's actually not difficult. These are the steps. In order to find out the standard deviation, you have to find the mean. Second, subtract the mean from each score. Then you have to square each deviation. Then find the average. Then take the square root. These are the 5 steps you have to follow to find out standard deviation. Right. In order to identify what is standard deviation, I'll go here. With this deviation, this one we have already, I'll explain it with this one. Deviations, so far the standard deviation. Last time we discussed. Likewise, this one also QD we discussed. Q3 minus Q1, like that we study. Quartile deviation, and percentile deviation, mean deviation, standard deviation. Let's see what's very simple. Don't worry, it's very simple to understand. Quartile variation, last time we studied. You can remember, go through it and play, understand. You can remember. Equation we wrote like this. QD, quartile deviation, means Q3 minus Q1 divided by 2. QD means quartile deviation. Q3 means third quartile or upper quartile. Q1 means first quartile or a lower quartile. The absolute measure of quartile deviation. And the interpretation of the quartile means a small quartile may වෙනස පොඩි වුණා නම් small value එකක් වුණා නම් or මොකක්ද වෙන්නේ? මොකක්ද වෙන්නේ? Let's see. These are the steps. I think we have done this one earlier. For to remind you, I have put here. You see, these are the data series here, X and frequency. Okay, what we have to do, QD, Q1, Q3 minus Q1 is the equation of step 1, calculate Q3. Step 2, calculate Q1. Step 3, calculate quartile deviation as quartile deviation Q3 minus Q1 divided by 2. Q2. This is the equation. Here you see, there are 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Right? Q1. How to find Q1? Size of n plus 1 divided by 4. Last time also we did. N means 1, 2, 3, 4, 5, 6. Right? The frequency. Number of frequency. Total number of the frequency. N, here 6 plus 1. 6 plus 1, 7. We have to divide the 7 by 4. Then 1.75. The size of 1.7 here we have to find like this. 1.75, no, the size of 1 item plus 0.75. Let's see. Here, first one, what is the value of one item? 1. The first one, 5. The first frequency's value is 5. So we write 5 plus, this is 0.5. Is that right? This number lies, CF, can you remember? Using this CF, can you remember here? Here is the CF. 1 here. So 1, we write 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. Terminative frequency we found it last time I explained you. So here, 1.75 means it is somewhere between here. 1, 2. Between 1 and 2, no, 1.75. So what's the value of 1? 5. Here you put 1. Here plus 0.5 means this 0.5. This is here 0.5. Put a bracket. 15 means here 2. The second, between these two, no, this value is 15. This value is 5. So you reduce, subtract 15 minus 5. Then 10, you multiply it by this one. Then 7 plus 7, 5. Then Q1 is 12 plus 5. Right? Here, you have to find out, this is Q1. Again, you have to find out what? 3, right? Q3, how to find Q3? Q3, 3, because the Q3, no, we divide half, part, half, 25%, 50%, 75%, 100% like that. Now we do. So, mean Q3 means here 3 into n plus 1 over 4. Here also I told you last time. If we bracket it and put 1 in front of, it's the same value comes. So we ignore here 1, but here we have to put the 3. Then the value is 5.25. Then 5.25 means it's somewhere here between 5 and 6. Here you have to write the 5. What's the value? 45. That's why here 45. Again, 2.5 no here plus 0.5. Within bracket, these two. This is the large number 55 minus 45. Right here, then you can get 47 plus 5. Then when you substitute 17.5. Again, I have another example you can do. Individually, you can do it, find it out. So, you can find it out and you can see, you can compare the earlier lessons example and you can understand. That is the deviation, QD deviation. Yeah. Right? Now, again, we already talked about this. The same slide I have put here. I think you can remember. I think you can remember. Yes, see. Now I have visualized it to you. This is the population. This is the sample. From the population, you take some certain number of the the variables and you variance and you study. Right? This is already I explained you. Mean, sample mean, population mean. Here you can see again mean deviation. If he means we said here new terms come, so you don't confuse. This is the quantile deviation. Now we are talking about the mean deviation. Mean deviation means mean deviation. කියන්නේ mean එක බලමු මොකක්ද කියලා. mean deviation එකට මේක අපි දැන් බලපු එක. sample mean එක මෙහෙම count කරනවා. mu කියන්නේ population mean, x bar means sample mean. You already know it. Sample deviation, mean deviation. To find out the mean deviation, first we have to find the mean. This is the given data set. Then mu. We add all the numbers and 1, 2, 3, 4, 5, 6, 7, 8. So 8. We divide by 8. 72 by 8 equals to 9. Mean. Actually, this will come as x bar. This is a population mean, not the population sample mean. We can say both as the population mean as, here 1, 2, 3, 4, 5, 6, 7, 8. From these 8 numbers, if we take 3 set of numbers and characters and we study, then it will come as the sample. Don't worry about that. Absolute, then we have to find the absolute, mean deviation. X. Right? Here you have already found the mean. value. Mean value is 9. Mean deviation means x means the row number, no data, this value minus mean value. Here we have put simple like this. This is called the mod. Mod means that ඍණ වලින් උත්තරය ආවත් ධන වලින් උත්තරය ආවත් we ignore what's minus and plus. We don't worry about the minus or plus in mathematics. Like that. Here see sum. This is what the total or sum. Right? This is what now this say. This is the x value given value. Then x minus mu means here 3. X means 3 minus mu means 6. Sorry, 9 equals to minus 6. It comes as minus 6, but because the equation says like this, no? Here, the equation is so we ignore minus. Here we don't, whether it is minus or plus, we ignore. And we write as plus here. The plus minus, you can ඍණ ධන numbers වලින් තියෙන එක ignore කරලා ධන number ඍණ number එකක් ආවත් ධන number තමයි දාන්නේ. ඒ කියන්නේ 3 අඩු කරොත් 9. ඒ කියන්නේ 3 minus 9. 3 ඍණ 9නේ. එතකොට ඒක උත්තරේ එන්න ඕනේ ඍණ 6. ඒ වුණාට අපි මෙතනින් ඍණ කියන එක ignore කරනවා because of this model. We write plus 6. Right? Then may higher method, no? X means 6, 9. Mu mean 9. Minus 3. Then we ignore and we write 3. Here, again the same. Here, 2. 8 minus 9. Then 2. Like this. Then sigma make it total 30. You have to, now you have found this one and you have to divide by 9. Give a single minute. Right. The value we have found here, right? That is 30, here 30. N means 8, we already know 8, 3.75. දැන් තාම ඔයගොල්ලන්ට තේරුම් නැත්නම් මේ දැන් අනිත් ස්ලයිඩ් එකේ බලමු. මේක බලන්න you can understand it easily. This is the, here, see, this is the data series, no? This is the given data series. Here, series. What is this? 9. 9 is the mean value. Mean value. That's why here in red, this is in the data series. All the data are not given to us. We have here 0 to 18 like that here. 9 is the middle. Here in the given data set, we have 3. Here 3. What is the other number? 6. 6 appears 2 times. Then 7. Then 8. Then 11 appears. That's why the yellow lines indicates the numbers given to us in the data series. Then here say this is the mean value. This is the mean. දැන් බලනවා මේ mean කියන එක අර මේ average එකක් නේ. මේ average 9 නේ අපිට මෙතන එන්නේ. ඒ නම්බර් එකෙන් 3 කියන අර අපිට දුන්නු වැලියු එක කොච්චර ඩීවියේට් වෙලා තියෙනවද? ඒක තමයි මෙතන 6 කියන එක කොච්චර එහාට ගිහින් තියෙනවද කියන එක තමයි මෙතන පෙන්නන්නේ. මේ 6 කියන එක. 6. How it has deviated. These three, again 6 now, 6, 6. Yeah, there's a here see 9. The, the actual data is 6 here. 3. The gap between these two is 3. Here the actual data is 7. 7, 7, 7. Here also comma. Here also should come. And the actual data here is 8. What is the difference? 1. Mean value between this one, 1. And here the actual data is 11. Then the difference is 2. These sides are minus side. These sides are plus side. Winner, done. Right? 16. 16 means here, somewhere here. The 15 means here. This is here. The gap is between these two values, 6. 16 is here. The gap between the real value and the mean value is 7. So we have taken the gap values and we have add here. You see, 6 mean the gap value. 3 gap value. Here gap value. 2 means the gap value. 1 is the gap value equals to this side. I mean this side. Here, this is 9, no? Here. 9ට අඩුයි මේ සංඛ්‍යා ටික. mean value ට අඩුයි. මේ සංඛ්‍යා ටික mean වලට වැඩි. So mean value this side, right side. So 2, 6, deviation 6 and 7. 15, 15. දෙපැත්තම විසිරලා තියෙනවා. mean එකෙන් මෙහාට දෙපැත්තම විසිරලා තියෙනවා. 15 කියන එකේ නම්බර් එක. This is what the mean deviation. Exact mean value එකෙන් given data වල තියෙන නම්බර් එක කොච්චර deviate වෙලා තියෙනවද? ඒ සංඛ්‍යාව අරගෙන ඒවා ටික ඔක්කොම එකතු කරලා ඒක frequency එකෙන් divide කරාම mean deviation එකක් අපිට එනවා. හරිද? අපි ඒවා බලන්නේ population එකෙන්. අපි බලමු. හරි. එතකොට මේකනේ බැලුවේ අපි මේකේ let's see this one. Mean value. Population. Then බලමු mean value. After that we talk about the mean standard deviation. You now remember about the picture I show you, the camel's pictures. Standard deviation. It's a kind of a statistic measure. Right? What does it say? Standard deviation is a statistic that measures the dispersion විසිරලා යන ප්‍රමාණය of the data set relative to its mean. mean එක කොච්චර දුර එහාට මෙහාට විසිරලා තියෙනවද? actual අර mean එකක් අපි ගන්නවා. ඒ mean එකෙන් actual data ටික එහාට මෙහෙට විසිරලා තියෙන්නේ කොච්චර distance වලින්ද? කොච්චරක් අර gap එකක් ඒවා අතර තියෙනවද? කියන එක තමයි standard deviation එකෙන් බලන්න යන්නේ කියලා කියන්නේ. So the standard deviation is calculated as the square root of the variance by determining each data point variation relative to the mean. It provides insight into how much variation or dispersion gap exist from the average, mean, or expected value. Right? Population. You know now what is population. All these things are very important when we do the research part, statistical analysis part. Right? Population sample. Now you know what is sample and what is population. This one also standard deviation. Last time I introduced you. This is, here see square root. Here see square root. This is square root. We call it as square root. Here, this symbol is called as rho. This is standard deviation. This is, if we find it for the population, then we say as rho. If it is if we consider about the sample, the standard deviation, then we say is, right? Yes, square root, square root. What's the difference between these two equations? Here also sum of, or total of x minus mu. Mu means, now you know its mean value. Here also x bar. Here x bar, here mu. You know it. But here you see, here capital N is given here, total population size, number of the population. Here, simple N is sample number, sample size. Here, according to this picture, 1, 2, 3, 4, 5, 6. That is N. Here, simple N. Capital N is all these people. If we count all the people, that number is here capital. It is indicated by the capital N. Here simple N, we have to minus 1 according to the equation. Here we write minus 1, but here we don't write. That is the difference between these two equations. Right, again I have given you the same equation. Standard deviation, right? Standard deviation. Here, this is actually now you can understand very well. This is a given data set. What has given? Height of the children. Let's say height of the children. How many children are here? 1, 2, 3, 4, 5, 6. Or let's say 6 students. 1, 2, 3, 4, 5, 6. Here the variance or character we consider is their height. We have to find the mean value indicates their average height normally. That's what here. The mean value here, this line, the green line indicates the mean value, 155. How we get it? Here according to the equation, right? But that is the mean value. Real value of real height of the first student is 173 centimeter. Here, centimeter, let's say it can't be meter now. Here, the second student's height is 147. The third student's height is 140. The fourth student's height is 163. The other students, the fifth student's height is 146. And the sixth student's height is 161. This is the mean value, average value එක. එක deviate වෙනවා නේද දැන්? ඒ කියන්නේ gap එකක් තියෙනව නේද? Real value, mean value අතරයි each student's height. This is the average height. This is each student's height. There is a gap. CSC. This is the equation we use for standard deviation, right? The same equation, this one or this one. And if you look at it very carefully, this one and this one is the same. Okay? Here, see, I'll explain it later. Here, see, there is a gap between the mean value and the exact value. Now, can you remember? In the mean deviation also we found it. This is x minus x minus x bar. Can you remember in this one, you did the same thing. Here, you get the 9 average and how it deviate. The deviation you found. Similarly, here also we found first the deviation. Here, this is the average. Then it deviate from the each student's height is deviate from the mean value. සමහර ළමයිගේ mean value වට වඩා උසයි සමහර ළමයි ඒකට වඩා කොටයි. එතකොට gap එකක් තියෙනවා mean value එකට actual ළමයිගේ height එකටයි අතර. දැන් මෙතනදී අපි කරන්නේ standard deviation එක forget it about the root. Square root ගැන අමතක කරලා මෙතන තියෙන මේකත් අමතක කරලා වර්ග කිරීමත් අමතක කරලා මේ දිගා බලන්න. 173 minus 155. මේක mean deviation එක. ඒ කියන්නේ මේ 155. This is 173. Then the gap. This gap. Here they have taken. Right? Then what we have to do according to this equation, what we have this value. We have to varga kirima. Right? That's what here they have written. It is written here. Similarly, for this one, 147 minus 155. Square, bracket, then varga kirim. Remember, 161 minus the square root divided by 6. මේ 6 එකටත් මේ square root එක එනවා. This is the given SD. Equation for SD. Here see, summation or total summation of x minus x bar. Okay, varga kirima. X is the mean value for all the persons. X is the height of the individual person. එක තමයි මෙතන අපි කරන්නේ individual person. Then what is this? 1 over n is the number of the people. Here 1, 2, 3, 4, 5, 6. And here sigma rho is the standard deviation. Here see deviation. Equation බලලා බය වෙන්න එපා. Very simple thing is there. So the gap here between these two, 173 minus අඩු කරලා බලන්න 155. Let's try to find the value. What is the value? 173 minus 155 equals to this one. I'm telling about this one, not the වර්ග කිරීම නෙවෙයි. මෙතන තියෙන gap එක 18. මෙතන බලන්න මේ වර්ග කිරි මේ කියන්නේ what is this part? වැඩි කිරීම මේක නැතුව මේක ඇතුල් bracket within bracket කියන numbers ටික consider කරන්න. 173 minus 155 equals to 18. يعني gap එක මෙයයි ඒ කියන්නේ mean value අතරයි මේ individual එක පුද්ගලෙක් ගත්තනම් මෙයාගේ first ළමයාගේ උසයි අතර තියෙන difference එක නැත්නම් gap එක කීයද 80 18 centimeters. එයා උස වැඩි mean value ට වඩා. අනිත් ළමයා 80 cm. මෙයා අඩුයි. එතකොට gap එක කීයද? අරයාගේ value එක කීයද? 147 minus 155. Don't consider about these two. With only consider about the bracket. Then this gap value is 18 centimeter. Right? You see 50, 18, 19, 16. Sorry, 6. Sorry, not 18, 8, 15, 8, 9, 6. වැඩි අඩු උස වැඩි එක උස පරතරේ ඉන්නවා. මේක තමයි average. දැන් ළමයි ලකුණු ගත්තා. This is the average mean value. Each student's marks will be deviated from the වෙනස් වෙන්න පුළුවන්. Right? This is the mean value එකෙන් ළමයින්ගේ ලකුණු මට්ටම වෙනස් වෙන්න පුළුවන්. ඒක තමයි මෙතන consider කරන්නේ අපි. Right. Now here see. මේ equation එකේ. This is the equation. Square root මෙහෙම කරලා මේක divide කරලා මෙහෙම කරන්න. Mathematical part එක. Sample variation. ඔයගොල්ලෝ බැලුවොත් එනවා. ඒක calculate කරලා හරියටම calculate කරලා බැලුවොත් එනවා 32.25 centimeters. Yeah. Right? Make substitute. You have to substitute here and find this value. That value is SD. Here you substitute, and that is 132.25. The variance is more difficult to interpret because the unit is square of the unit ගැන කතා කරොත් අපි මේ individual දැන් height ගැන නම් ඒක centimeters වල නම් එතනත් අපි මෙතනත් දාන්න ඕනේ centimeter squared. එමයි එන්නේ. අර උත්තරේ එනකොට ඔයගොල්ලෝ කැල්කියුලේට් කරලා බලන්න. එතකොට ඔයගොල්ලන්ට තේරෙනවා. එකින් එක කැල්කියුලේට් මෙතන කරන්න අමාරුයි. හරි. Now the difference. කියන්නේ මේක දැන් මෙතන මොකද්ද කරන්නේ? මේ difference එක අරගෙන ඒක ආය වර්ග බලය ගන්නවා එකේ. ඒකනේ කරේ මෙතන බලන්න. මේ difference එක අරගෙන ඒක වර්ග බලයෙන් එකින් අරගෙන ඊට පස්සේ ඒවා කොහොම එකතු කරලා මේක 6න් divide කරලා බෙදලා ඊට පස්සේ එන උත්තරේට ස්ක්වයර් රූට් එකක් බලනවා. එහෙම කරද්දී අර deviation එක හරියටම අපිට clearly පේනවා. දැන් mean එක තියාගෙන කතා කරනකොට අර gap එක වැඩි. ඒක තවත් අර population එකක් දැන් මෙහෙමනේ සාමාන්‍යයෙන් ස්ටැටිස්ටික් වල population මෙහෙම එකක් අරගෙන අපි මේම sample එකක් අරගෙන දැන් අපි යමක් කතා කරලා රිසර්ච් එකක් කරලා මේගොල්ලන්ගේ height එකක දැන් මේක weight එක ගැන කියලා හිතමුකෝ අපි let's say weight we think the mean value ගත්තා mean value එක අරගෙන මේ යම් කිසි mean deviation එක තියාගෙන නැත්නම් mean value එක තියාගෙන සම්පූර්ණ මේ population ගැන weight එක ගැන අපි කතා කරන්න ඕනේ generalize කරන්න කියන්නේ ඒකයි මේ සාම්පල් එකේ weight ගැන අපි කතා කරනවා නම් අපි කියමු මේ සාම්පල් එකේ වැඩිම ළමයි ඉන්නේ overweight ළමයි නම් අපි යන්නේ මේ population එකෙත් වැඩි يعني large number of students have the overweight. එනවා generalize කරන්නේ. එහෙම generalize කරනවා නම් researchers වල එතකොට අපි හරියට මෙහි කතා කරන්නේ. ඒක දැනගන්න ඕනේ. mean value එක තියාගෙන ඒක මේ statistically අපිට හරියටම population එක weight එකට generalize කරන එක අමාරුයි. අර deviation එක කියලා කියන්නේ statistically. ඒකත් අර ඒකේ ඇතිවන අඩුපාඩු මකා හැරෙන්න. ඒ කියන්නේ ඒක නැති කරගන්න. එතනින් අඩුපාඩු අපිට ඒවා generalize කරන්න easy වෙන්න තමයි standard deviation එකක් ගන්න. අපි හැමතැනම මම ගියසරෙත් I told you when we in the research we always talk about when we generalize something then we give the mean value with the standard deviation. Likewise we discuss. Right? Here that what happened. Here again I have written it for to recall, this is the population standard deviation. This is the here if it is capital N, it is the population standard deviation. If it is N minus 1, it is sample standard deviation. The equation formula different, somewhat different. What is number of values in the population equals to N number of values in the sample, but here minus 1. This is equation. This is a statistical equation. So again, this is the equation. Right? So why do we need all these things? This is what we taught. Right? This is an example. Right? This find the standard deviation. I have told you here now the steps. I have given you the steps. How we find standard deviation. How we find where the steps. I have given you the steps where it is. No, not this one, not this one. Not this one, not this one, not this one, not this one. Where we study, I have given you the step. I can't remember now. Somewhere I gave you the step. Here. Standard deviation we talk about. I told later I will explain like that. Here see these are the steps you have to follow when finding the standard deviation. Here, these are the steps. So why we need a interpretation? If small sd, I mean standard deviation, කියන්නේ deviation එක අඩුයි නම් standard deviation එක value එක small නම් හොඳයිද ඒ data set එකේ අපි ළමයිගේ ලකුණු ගැන තියාගෙන කතා කරමුකෝ. If we consider about the marks of sports maths වලට හෝ science වලට ළමයි ගත්ත ලකුණු කියලා හිතාගෙන කතා කරොත් small deviation කියන්නේ deviation එක අඩුයි. mean එක ළඟටම ඒගොල්ලන් cluster වෙලා spread වෙලා ඉන්නේ. අර ගියසරේ මම පෙන්නුවා පොඩි අර circle දෙකක් දාලා pictures දෙකක් cluster වෙලා තියෙන හැටි spread වෙලා එක round එක cluster වෙලා තියෙන එක ඒකත් බලා ගන්න. If it is a large ST, the scores have spreaded. Which one is good? If we have a small ST or a large ST? If it is small, all the students' marks are very close to the mean value. That's the interpretation, or that is the explanation. If SD is large and the standard deviation is large, that means students marks meanwhile එක එක ඉන්ඩිවිජුවල් ළමයාගේ මාක්ස් අතරයි ඇවරේජ් මාක්ස් අතරයි තියෙන ගැප් එක වැඩි. ස්මෝල් DSD කියන්නේ ගැප් එක අඩුයි. කොකද හොඳ? ස්මෝල් වැලියෝ ළමයි ඔක්කොම මීන් වැලියු එකට ලං වෙලා ළමයි හැමෝගෙම ලකුණ තියෙන එකද හොඳ? ඩීවියේෂන් එක කියන්නේ ගැප් එක ගොඩාක් එහාට මෙහාට විසිරලා ළමයිගේ ලකුණු තියෙන එකද හොඳ? කියන්නේ ළමයි අතර පරතරය වැඩි. හැමෝගෙම ලකුණු මීන් වැලියු එකට ලං වෙලා අර ගැප් එක අඩු වෙලා ඉන්නවා නම් සමස්තයක් වශයෙන් අපිට ගන්න පුළුවන් මේ ළමයි කණ්ඩායම මේ මීන් වැලියු එක අතර තමයි ඉන්නේ කියලා. ඒගොල්ලන්ගේ ඩීවියේෂන් එක මෙච්චරයි ඒගොල්ලන් එහාට මෙහාට වෙන්නේ මීන් වැලියු එකේ. එතකොට සමස්තයක් ඒගොල්ලන් අපිට ගන්න පුළුවන් මේගොල්ලෝ මෙච්චර ප්‍රමාණයක් මේ කණ්ඩායම ලකුණු අරන් තියෙනවා කියලා. Right? Then if we get a small SD, it's good. If it is, we can generalize. But if it is large SD, it's very difficult to generalize. It's not good. The test is not good. We talk about the reliability, validity, like that. We talk about, you can connect with that. So uses all the data values least affected by the sampling function. Essential for understanding the normal distribution, we will study. Widely it's used in research testing and development. So what's the time now? Right. So now I hope you have understood. Here there are some. This short novel. Here these are some problems given to you. How to find standard deviation. So here the data set is not grouped. That means ungrouped data set. This is the ungrouped data set. Here the data set is, wait, give me one. Hi. දැන් බලන්න. Sorry. Here This data test is not grouped, ungrouped data set. We have two type of data set. I mean, in the sum, in the problems, we will be given two type of, I mean, in the sum, data will be presented. I mean, we normally we present the data, I mean, in ungrouped wise or grouped data. Ungrouped data, group data, right? This is ungrouped data. Only 20 numbers are here. The frequency total is 20. Then now you know already about this. To find the meaning, sorry, mean, we have to find fx. Then we have to summation of fx. Then this is the value 70.25. The, the very mean of this data set is, ungrouped data set is 70.25. This is the first step. In the second step, you have to find this one. What is the second calculation? You have to, I mean, in order to find the standard deviation, right? This table, you see we have, I mean, one more information is x minus x bar. Here see, we have to calculate this one. In order to find out this one twice, I mean x minus x bar value into again, we have to get the x minus x bar. That's the meaning now. So x be like this, x minus x bar, right? Here already we know 70.25. So 70, this is 70.25. Here, this is 55. This is x means here 55 minus 70.25. So the value is minus 15.25. Here the x is 60 minus x bar is 70.25. Then 75.25, yeah. 75.2 means can't be happen. No, here it should 75. No, come. 75 it should come. No, something wrong. Exactly. I mean here I can name the 55 value 70. මෙතන 25 දශම 2.5නේ. එතකොට මෙතන එන්න ඕනේ 7.5 කියලානේ නේද? එතන එන්න ඕනේ එතන 7.5 දාගෙන ගිහින් තියෙන එක හරි. එතන පොඩි වැරදීමක් වෙලා තියෙනවා. sorry. මේ 75 කියලා නැහැ මේකෙන් එන්න ඕනේ නේද? 55 මේ 65 නම් 65 minus 70.25. ඉතින් 70.25 වලින් ඉඳන් හරි. sorry. හරි. I got upset. Right? Here like this you have to. Then you have to this value. Here you have find this value. Then you have to multiply, I mean 2 times of this value. 2 times. That means 50 minus 15.25 into minus 15.25. That value is 232.56. Right? Like that. So, here you need this one. Then you get this value. You have to multiply by f. Here you have this value. Then you multiply by this. Then summation of then 1823.70. Here this is the value. This is what now we have found using the table. Using this table, we have found this value. We have to divide, we have to substitute here, then we have to divide by 20. That is the number of, total number of, that means summation of frequency. Square root, here see the square root, the all together it comes. Square root, then the value is 9.55. Standard deviation is 9.55. Interpretation on average student scores deviate from the mean by about plus or minus අඩු වෙන්න පුළුවන් or වැඩි වෙන්න පුළුවන්. That's why වැඩි නම් plus අඩු නම් minus. Marks showing moderate variability. අර වෙනස. ගොඩාක් අඩුත් නෙවෙයි ගොඩාක් වැඩිත් නෙවෙයි. Here there are sums you can do. For your practice, I have given, you can practice it, check your answer. Here, this is ungrouped data set. Frequency. Here, what is this? Huh? Try to calculate. In order to calculate the standard deviation, first we have to find out the mean value of the data, given data. Then we have to fill this table. And you can use those things. I mean, try to do, then you can, it will be clear for you. The standard deviation is the, now again I am repeating the same thing again and again in order to make clear it to you. The standard deviation is the average amount of the variability in your data set. That is the variability. Now here we said, here, variability and the data set. It indicates an average how far each value lies from or deviate from or the gap between the mean value. The high standard means that values are generally far from the mean, while a low standard deviation indicates that values are clustered closer to the mean. So in a data set, if we get a small, I mean, SD, it's good. Here, decoding, what is the distance? So this is what we find first, mean score. Then square root in order to remove the negatives, and that means minus values. Then sum of squares divided by n, average variance. Then we have to find the root, square root, SD. Actually, you don't need to memorize these equations, all these equations. It will be given. Nowadays, there are apps. We have to feed, we know, if we feed the data, they will give us the values, SD value. But we should know the theory behind it. If you give some data set and ask, even in the Excel, you can find SD. Minitab, and there are so many apps. They will calculate and give you directly. No need to, memorize. And but we have to understand the theory behind it. Why we need those things. Just understand that we are measuring how far on average students, deviate from the center. Center value is the mean value. Not 10. What are the values? Center values, three values we have. Mean, mode, median. Here, group data. The data has grouped. You see the difference between these and the group. This is the frequency. Then we have to find the middle point first. What we have to do? First, we have to find the middle point. In order that see middle point. This is how we find the middle point. Here, right. Here you have already find the middle point. You have already found the middle point. Now what you have to do? You have to multiply f and x. F into x. Fx and summation. Total value. Right? Then you have found the total value as this. This is the mean value. Then what is the mean value? 69.7. I mean approximately 70. The average performance of the class is around the credit pass level. Right? What can we understand? What's the message give you? It gives us the mean value. What's the decision we can make with the mean value? I mean, the average performance of the class is around the credit pass level, 70, not over 75. Teaching and assessment appear moderately effective. We can say teaching is if all the students can get around, I mean, average is 70, it's good. Right, third step now. What we do, we have already found this one. This is the mean, I mean, x minus mean value. X minus mean value. X bar, no, this is this one. X minus x bar. This is. Then what we have to do? Ready, this the yes. But then we have to multiply the answer with, I mean, f. Then we will get this answer. What we have to do next? We have to substitute. You have to substitute. මෙතන FD කියලා F මේ දැන් ඔයගලන්ට දෙන I mean you will be given the equation. Equation will be given to you. According to the given equation you have to do. Here summation of capital A. Not summation of I mean n minus simple n minus 1. Here according to this equation this is the answer. If it is n minus, that they will give you the equation according to that equation. You have to find it out, right? Then this is the mean value and standard deviation is 16.6, right? 16.6. What does it mean? You can calculate it using if n minus 1 also. If you can here write if here 50 no 50 minus 1. Then you calculate the SDN check. What happened? So let's say here mean value is 60.7 and SD is 13.6. What does it mean? Most of the scores between, I mean, spreaded between what this I mean both side it has spread you can see this picture here the like this like that. We have again this is the this gap, this is the standard deviation here. See Mean value, when we get the mean value, it deviate from like this. Then here, the red color, the dark area, this is the standard deviation. We have average it also. We have add all these things and find the average of it again. So that's why the gap is 15 point over this one and 15 point below, over and below. I mean, not 15, 11.5 here, spread it. Like this we have come, broke it. Now imagine it's in the bar, I mean this two, this gap. Here, 11.5 plus. Below 11.5 means minus. Between these two, the scores, I mean, we have averaged and wrote it up now. That's the I mean, this area, the dark area is described by the standard deviation. This is the mean gap. Mean deviation, mean deviation, mean deviation, mean deviation. We have take, so here, this one. That's why here it says 15. If we reduce 60, I mean, මේක අඩු කරොත් මේ සයිඩ් එක එනවා. මෙහා පැත්තට. ඒ කියන්නේ ලකුණු අඩු මට්ටම. ස්ප්‍රෙඩ් වෙලා තියෙන 56යි මේ පැත්තට මේක එකතු කරන්න ඕනේ. එතකොට 83 කියලා එනවා. කියමුකෝ. ඒ කියන්නේ සාමාන්‍ය මට්ටමින් 56යි 83යි අතර තමයි හැම ළමයාගේම ලකුණු මට්ටම තියෙන්නේ. ලකුණු තියෙන්නේ. ස්ප්‍රෙඩ් වෙලා තියෙන්නේ. ඒකයි කියන්නේ. මීන් වැලියු එක කීයද? around 70 කියලානේ අපි ගත්තේ. 70 කියමුකෝ මීන් වැලියු එක. එතකොට මීන් වැලියු එක 70 නම් මේ ළමයාගේ ලකුණු කොහොමද පැතිරලා තියෙන්නේ, ස්ප්‍රෙඩ් වෙලා තියෙන ළමයි සෙට්ගේ අඩුම, ඒ කියන්නේ මැද හරිය අපි 70 කියලා තිබොත් 70 වලට අප් කීයද? 83 වගේ වෙනකම්, below 53 වෙනකම්. ඒකයි අර ගැප් එක කියන්නේ අපි. ඒ ගැප් එක වැඩි වෙන්න ලකුණු ස්ප්‍රෙඩ් වීම වැඩි. ඒක හෙච්චන හොඳ නැහැ. ඒක අඩු වෙන්න තමයි මීන් එකට ලං වෙන්න. ඒක තමයි මෙතනින් කියන්නේ. low SD mean uniform class. කියන්නේ කොහොම හැමෝම එකම වගේ ලකුණු මට්ටමක් ගන්නවා. high SD mean wide ability range. ඒ කියන්නේ ළමයි අතර පරතරය වැඩි. සමානකමක් නැහැ. දුර්වල ළමයින්ට ගොඩාක් දුර්වල අයත් ඉන්නවා. හොඳට වැඩ කරන අයත් ඉන්නවා. එතකොට SD එක ලෝ කියන්නේ හැමෝම එකම විදිහට වැඩ කරන කණ්ඩායම සෙට් එකක් තමයි ඉන්නේ. ඒක කන්ක්ලූෂන් එකට අපිට එන්න පුළුවන්. high SD plus mean average mean need differentiated, එතනින් අපිට කියා ගන්න පුළුවන් මේක වැඩි, මේක mean එක average නම් mean එක වැඩි වෙන තරමට අපිට හොඳයිනේ. mean value එක දැන් 50 ආවොත් ඒක තව ක්ලාස් එකේ 70 ආවොත් අපි කියන්නේ 70 ආපු ග්‍රේඩ් එක තමයි හොඳ කියලා. ඒ ක්ලාස් එකේ ලකුණු මට්ටම හොඳයි කියනවා. එතකොට high average mean එකයි low මේ SE එකකුත් අපිට එනවා. එතකොට තමයි ඒක සාර්ථක දෙය තියෙන්නේ. අපිට low mean value එකයි high SD එකත් ආවම ඒ ටීචින් එකේ යම්කිසි ප්‍රොබ්ලම් එකක් තියෙනවා. එතන යම්කිසි ළමයිට ප්‍රොබ්ලම් එකක් තියෙනවා. එතකොට lower SD plus high mean means එතන ඒක හොඳයි කියලා. ඒ group එක හොඳයි අපිට ගන්න පුළුවන් තියෙන්නේ. එතන ළමයි හැමෝම එකම ආකාරය වැඩ කරනවා. So we have grouped these data. So we have here the class intervals. These are the frequency. We have them visually, in order to visually understand, we have drawn, I mean, we have here These are the here in the x-axis, I mean class interval. In the y-axis, frequency. The histogram comes like this. We learn about the histogram. Then midpoint of the bars, if we add, the graph will appear like this. Plotted graph will appear like this. දෙපැත්තම ළමයි ඉන්න අඩු ළමයිනුත් ඉන්නවා වැඩි ළමයිනුත් ඉන්නවා. මීන් එකට වැඩියෙන් ළමයි ගත්ත ළමයි සංඛ්‍යාවකුත් ඉන්නවා අඩුවෙන් ගත්ත සංඛ්‍යාවක් තියෙනවා. ඒ සංඛ්‍යාව අර පරතරය අඩු වෙන්න methodology teaching methodology ගැන කතා කරනවා නේ ඒක හොඳයි. ළමයාගේ performance ගැන අපි කතා කරනවා ඒක හොඳයි. ඒ spread වෙන්න ඒ ළමයිගේ හැකියාව ගැන අපිට ඒ කියන්නේ විවිධත්වයක් එතන තියෙනවා කියලා කියන්න පුළුවන්. මේ this is the one. So the graph comes like this, no? Yeah, the graph come like this. This is the peak. I mean, this is the mean value. According to this, like this, no? Yeah. So this is generalized graph. Here we are average performance. This side is the high performance. This side will be the poor performance or low performance. You see, in this one, this side is the low performance or poor performance. This is the average, and this side is the higher performance. We have tabulated this one, this data set into graph and this graph. Okay, now keep it in mind, this graph. So this is standard deviation. Here the difference. What is the difference here? What is the difference between these two? Here also standard deviation is 50, 100, 75. Standard deviation is 5. Here also standard deviation, sorry. Here the standard deviation is 5. Here the standard deviation is 50. When the later we'll talk about this. Okay. Now we have come to this part. Like this a graph we can get. So now we come to, I'm going to introduce you another concept, that is the normal distribution. The normal distribution describes a symmetrical plot of data around its mean value, where the width of the curve is defined by the standard deviation. It is visually depicted as the bell curve. I mean, normal distribution is called as bell curve. I mean, the curve. Here see, there's a bell-shaped curve we get like that. When we have a large, the population, when we talk about the population, we can get a graph like this. Then here we name the graph. This graph is as normal distribution or a bell curve or normal curve. The definition, the normal curve or normal distribution, or it is called as bell curve also because of the shape. The normal curve, also known as the normal distribution, is a symmetrical, right? It's symmetrical. 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 I mean, here see, symmetrical means we can divide it, this side and this side, the same. Look as, here see, symmetrical means here the gap, see the gap, 1, 10, 10, 10. Here 50, 20. What is the gap between these two? 30. Here this side 80, 50, 30. We can here see this is still symmetrical, same as this side and poor performance and the higher performance, and the same as if we cut it in a as a this way in a paper, we can divide it and get a same line. If we divide symmetrical. මේ පැත්ත එකම ආකාරයට ඒ කියන්නේ පරතරේ තියෙන්නේ same symmetrical bell shaped shape එක මොකක්ද? What's the shape? Like a bell shaped probability distribution that is commonly used in statistics to represent the distribution of the variable. Right? It is we talk here statistic. We are talking about the statistic. It is categorized by a central peak. Central peak. It is categorized by a central peak and symmetrically tapering tails. Here the tails, this part is called as the tail. This is not, if you ask to draw the normal curve, when you draw the curve, here there's a gap. Always there's a gap between the x-axis and this line and the bottom line, baseline and the curve. The baseline and the curve do not meet. That's very important. You see, like this. That's what the other sentence typically forming a bell-like shape. That is what we say this, like a graph like this. Here these two lines should not touch. This is the baseline, the blue line. The green line should not touch the blue line. Just go above. Right? Just little bit go above like this. Here, like this. You should be very careful when drawing the graph. Right? This is called the normal distribution. Data symmetrically distributed. දෙපැත්තටම සමානව ළමයි අරන් තියෙන්නේ. poor performance ගන්න ළමයි වැඩිත් නැහැ. Higher performance ළමයි equal. Both are equal here. That's why normally distributed, we say. With no skew. This is normally symmetrical. Most value cluster around the central region. You know what is the central, what is called central tendency, mean, mod, median, right? With values tapering off as they go further away from the center. This is the center line, this X. This side and this side are same. The measures of the central tendency, mean, mod, and median are the same value. Let's see. Here, mean equals to, according to this graph, normal distribution, mean equals to median equals to mod. That means the majority of the scores cluster around the mean. What is the definition of normal curve? The normal curve is a symmetrical, bell-shaped curve representing the normal distribution of test scores. Right? Important. Why is it is important? Basis for grading, ranking, and standardization. Widely used in national examination Sri Lanka. According to this table, Here see, according to they are higher performers. They are lower performers. Here see the blue, dark blue and the light blue, lower performance, higher performance. This part here, 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 let's see where. Here, this, the normal curve, I have, okay, I'll explain it later. There is a rule when drawing this one. Here, see the empirical rule or the 68, 95, 99 rule tells us where most of the values lie in the normal curve. What is this rule? 68, 95, 90.57. Here, see, according to this 68, the distance. You see, 95, 99.7 spread, right? And around 68 of percent values are within one standard deviation of the mean. Here see, this is deviated from one standard deviation. The gap between the middle line and this line, this part is one standard deviation. The gap indicates the one standard deviation. This is the 1 plus 1. From here to here, 2 standard deviation. Here, 3 standard deviation. Likewise, here from here to here, 1 standard deviation. I mean, between the blue lines. I mean, here, between the middle point and the 50 and 60. Between 50 and 70, there are 2 standard deviations. Between 50 and 80, there are 3 standard deviations. Altogether, there are 60 standard deviations. This is the one part. You have, I mean, 40, 50. 50 is the standard deviation. I mean, here lies, then this is the, I mean, this is the mean value. Let's say the 50 is the mean value and the standard deviation is 10. Then this is the lower part side, no? Then we have to 10. Reduce 10. Then 40. Then we reduce 10. 30. Again, reduce 10, 20. Here, one standard deviation between 40 and 50. Another standard deviation between 30 and 40. Another standard deviation is there between 20 and 30. Then this side's 3 standard deviation and I mean lower performance side, I mean below the average line, 3 standard deviations, and the other side, higher performance side, that means higher the mean value, there are 3 standard deviations like. That's what the rule. Right? Here see, this is the middle. This is the, I told 68, 95, 99 rule. I mean, spreading like this. This is the normal curve. Here, this curve also explain you more about the, it gives you further understanding. You look at that, I mean, this graph and study, get an idea. I'll give 1 minute, you get an idea about the graph. You see? This is a mean average. Standard deviation gap. Right? What does it say? Like you can understand. I mean, you can how to try to understand this one. I'm not going to explain this in more detail. And one standard deviation gap between mean and mean, the both side. That's why we plus and minus. That's here. This side and here. This is 68 now. That's what it is summarized here. So, what is the difference between standard deviation and variance? Variance is the average square root deviation from the mean, while the standard deviation is the square root of this number. You try to understand with the equation. Both measures reflect variability in a distribution, but their units differ. Right? Standard deviation is expressed in the same unit as the original value. That means minutes means standard deviation also we talk in minutes. If it is meter, we talk in meters. But the variance is expressed in much larger unit, meters, square like that. Although the units of variance are harder to understand intuitively, variance is important in statistical tests. They are not so much of it. You have to understand what is variable, variance, what is standard deviation, what is mean, like that. Why the standard deviation we need? That means, although there are simpler ways to calculate variability, the standard deviation formula gives us an unevenly spread sample than to evenly spread ones. A higher the standard deviation tells us that the deviation is not only more spread out, but also more unevenly spread out. This means it gives us a better idea of our data's variability than simple measures. That means such as the mean and absolute deviation. Mean deviation we talk about, that's what mean arithmetic deviation. MAD is the smaller to the standard deviation. The beginning of the lesson, we talk about the mean deviation. That was talking here. Here, see sample, mean, absolute deviation, mean deviation, standard deviation. You can remember, I show you the lines. So mean deviation, what is now already I have explained about the mean absolute deviation and standard deviation and mean. Two set of data, A and B sample data has given here. We can for further understanding. Here the both set of data's mean is 50. The set of data is sample A and sample B. In both samples, there are values for the, let's say 4 students are there. This is the maths marks of 4 students from A group and B group. The both group have the same mean value. At the same time, the both groups have the same mean deviation, the mean absolute deviation value at the same number. The both have different standard deviation. What does it tell us? What does it tell us? What does it tell us? the standard deviation is more precious. Now you know, if we talk about only with the mean value, here we can say both student groups are, same in their performance. They shows us equal performance according to this value. Average marks, both group have the same. Here all mean deviation also the same. But here, this is the smallest, according to these two numbers, this is the smallest standard deviation. This is the large standard deviation. Which group performed better? Exactly, the group A. Why? Because with the small, it has the small standard deviation. Yes, they are, here see the gap between the marks 66, 30. What is the lowest marks here? 30. What is the highest marks here is 66. Then the four students have scored between 30 and 66. According to this row, what is the lowest marks? 21. What is the highest marks? 79. According to this, the these students have scored between 21 and 79. Their marks range is between 29 and 79. Here see the standard deviation is large. The range is large, standard deviation also large. Here the range between 60, 30 and 66. Here small value. Then this group have, we can come to a conclusion. This group has performed well in this exam. Right? So that's why normal distribution. Again, I'm repeating these things because when I repeat again and again, you can understand and remember it easily. That's why I'm telling again and again. Mean value, mean, mu, the average value position at the center of the curve, representing the most frequently occurring value. According to this, you can imagine the standard deviation means the measure of quantifying the variability or dispersion of data, the gap, points around the mean. A large standard deviation creates a wider, flatter curve, wider, flatter curve, indicating greater data variability. Here see the data variability 21 between and 79, right? While a smaller standard deviation produces a steeper, narrower curve showing data concentrated closely around the mean. Here you can see now this is graph. I already had a graph, no? Here see, standard deviation 5. Here standard deviation is 50. See the difference between the graph spreader. This is what explained here. Narrower curve showing data concentrated closely around the mean. A larger standard deviation creates a wider, flatter curve. This is a normal curve. That's why, now you can see the difference. Why we say normal curve? Let's summarize the bell-shaped curve or normal distribution. It is a shape like a bell. also called a bell curve or a normal distribution. It shows how frequently different values occur in a population. It is symmetric, both sides are same, and has a single peak, and it is mean. The peak is the mean value. Its unique properties make it very useful in making statistical calculation. Here, for an example, you visualize again this diagram. According to this diagram, how most fish is in a given species fall pretty close to the average. This is the average, the second fish value, the peak. Very small here or large fish called outliers because of their uncommon size. The middle one. This is the common size. This is uncommon, small one. This is smaller than this one, and this is bigger than this one. Much rarer and show up on the end of the normal curve. Here the population like this, symmetric. This what it has given here, why this is 0, standard deviation. Here -1, -2, -3. This side standard deviation 1, 2, 3. Right? This is the mean value. We can't touch like this. I have explained you. You have to bring the line like this. I have taken the image. Some images use the wrong information here. The baseline and the graph line can't touch here. There should be a small, minor, tiny gap between these two lines. Here the population both sides, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This side see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the mean value. Below mean, over mean. This side is the lower performance side. This is the higher performance side. This is the peak. That means the peak says give us the idea about the average students. Here see, for your further understanding, here see this is the 50%, mean value, here see, according to this 50 this side percent and other 50 this side. If we take here, see, this is 50, this is 15, 10. 10%, seriously, what is that? Seriously underperformance, below expectation. This is these group of set of students meet the expectations, the average one. Then above the expectation, they are the excellent performers. They are the excellent performers in a group, in a class or a group of students. If we take analyze the O-level results, GC O-level examination results, GC A-level examination results, we can get a graph like this. The higher performance are there. Very few students get the merit pass and the examination, the A-level, the first rank, like that. Here also, lower performance, seriously, they failed the exam. This group of students failed in all the subjects. This group of set has got A passes in all the subjects. Like that. That's why we say symmetrical, right? 50-50. symmetry. This line indicates, mean value and the median value and mod value are the same. Here, this line gives us this value, if it is mean value 50, then median value is also 50. Then what is the mod value? Then it also 50. That's what the bell curve say. Symmetrical side. Here, I told you the baseline and the graph line can't touch. Sim what take. That's why we can say here. What is that here? Mean value equals to median value and the mod value symmetrically above the center. 50% of the values are less than the mean value and the 50% of the values are greater than the mean. This side and this side. These lines gives the idea. This is the mean value, baseline, this symmetrical line. Here, mean value, median value, and the mod are same. You try to understand the graph again. You try to understand the graph again. I have already explained. I have given some graphs for further understanding. You can get an idea. That's why I'm giving like this. Here, see, is the 68%. This is the 98%. This is the 99% of the students. Right? Why do we study the normal curve? The normal curve for the answer to the questions such as how are marks distributed in a class? Is the test too easy or too difficult? How do we compare students fairly? How are grades, percentiles, and z-scores are derived? This is the normal curve is used to find the z-score. You see, like this, according to this, if the mean value is 60, ST is 10, then likewise we can interpret or give the rank to the, grades to the students. This is the line, mod, mean, median, all are same. Now see what happened to the graph. Here, same. This line, the symmetrical lines tells us the mode, median, and mean value are same. But here, mod is the mean value. Green lines indicates the mean value. Median value. Mod value is large. So this side is the lower performer side is most of the students lies in the lower performer side. According to this graph, this is the mod, median, mean is here. No, sorry. Yeah, this is the mean, green color. Most of the students are on the right side of the mean value. That means most of the students have scored. Most of the students are in the higher performer side. According to the mean value. According to this graph, the green line, most of the students are here below the mean value. You can understand. Here you can see the graph and get an idea what the graph says. You can visualize it. So, if the graph is skewed according to the normal curve, this is now, can we say this is a normal curve? We can't say this as a normal curve because it's negatively skewed. Skewed. Here, many naturally occur phenomena in the real life. I mean, as the below, I mean, many naturally occurring phenomena appear to the normally distribution. For example, the average of height of a human is roughly 175 centimeter. I mean 5 feet and 9 inches, counting both males and females. As the chart below shows, most people conform to that average here, according to this graph. Taller and shorter people exist with decreasing frequency in the populations. Shorter people, taller people. Here, shorter people. Now, this side is taller people. According to the empirical rule, 99.7 of the people will fall within plus or minus 3 standard deviation of mean. Here, 3 standard deviation of mean. 3 standard deviation of mean. That means between 154 and 196. 154 and 196. The standard deviation is here. How? 190, 75 minus 168. Okay, the gap is 7. Right? Yeah. See the gap? Gap is 7. This 7, 14, 21, 7, 14, 21. The gap is here, see, 7. The gap between these scores. So the variance is computed as the average squared deviation of each number mean. Again, we come to the, here, variance, population. If we square root, then we get the standard deviation. This is the variance. Variance mean population, standard deviation. Considering about the population, standard deviation means you can see the differences. No square root, no square root, no square root. Standard deviation has square root. Here, standard deviation. This is if it is standard deviation because it has square root. Variance, it has no square root. That's the difference between the standard deviation and variance. Normal distribution, here, see, we have talked about this a bit. You can get an idea by looking at the graphs. Here, see, mean, median, mode lies. The normal curve represents a perfectly symmetrical distribution. This is not symmetrical. Negatively skewed. This is positively skewed. positive direction, negative direction. Shape of the data set, right? Again, I have like this. So, I have already discussed with you. Statistics are not about judging the students. They are about evaluating the learning environment. What is the test here? I mean, how did the question is, how did the class perform generally? The tool we use, I mean, using mean and median, we can explain it. And is my teaching consistent? Then, based on the standard deviation, we discuss it. If it is high, differentiate, we need to change our teaching methodology. Similarly, who needs immediate help according to Z score and fitness? I mean, repeating the same thing. The test analysis use skewness tells about the test difficulty. Positive skew, which is the positive skew. This is. That means difficult exam. Negative skew. This is the negative skew. What does it tell? It tells the exam is easy. Normal distribution curve, if it is the curve is lies like this, comes like this, it tells the balanced exam. Shape, again I'm summarizing about normal curve. What is the shape? Bell shape. Center, mean value, median value, and mode value lies. They are same. They all have the same value. Spread measured by the SD. Left side 3SD, right side 3SD. Use interpretation and compare. Compare and contrast the student performance. Limitation, not universal. This is not it. I mean, right. Now, so far we have, you please try to understand the concept. The other part is, normally we get the questions like this. I mean, do term test marks related to final examination marks? Can we talk about like that? What do you think? Now the students, the third term of the grade 11 students have exams these days. I mean, the third term exams. So, their performance in the third term examination, the relationship between here and the final. They are going to sit there, O-level examination. After that, they will get the result. When we come, if can we compare both results? There is a relationship. If a student get 9 A's in the term test, will he get 9 A's in the GCA O-level examination also? Can we predict like that? Do attendance related to achievement? Is there is a relationship between attendance and achievements of the student? Are boys and girls performing differently or equally? Is a teaching method associated with a better results? In order to find the answers, scientifically, we use in statistics correlation, scales and norms, and test of significance. Like that, these are some terms we use in statistics. Let's see. Correlation means the relationship. Correlation measures the degree and the direction of the relationship between two variables. Here, The variable is one is the test mark and the other variable is final examination marks. For example, we can say in education relationship between various, continuous various, we can see. For an example, term test marks and the final marks, intelligent test scores and the achievement score, study time is there is a relationship between study time and academic performance. Scientifically, we have to say. So, according to the correlation, is a statistical tool to measure the association between two or more uh, quantitative variables. It is concerned with the relationship between the changes and moments to variables. Correlation is also defined as the measure of the linear relationship between two random variables x and y. Let's discuss about it. There are three degrees of relationship in a correlation. If we take that's for an example. With the example, let's talk the term test, the study time, and academic effort. Performance. Is there a relationship between the perfect correlation means positive and the relationship may be positive or negative. Some degree of, perfect correlation means maybe it's positive or negative. Some degree of correlation means positive and negative. No correlation means there's no, right? uh, we are going to use, statistically, we use the graphs, equations. Here, see, positive correlation. That means this side increase, then this side x-axis also increase. This is the study. Let's say y-axis indicate the study time, and this is the study time of x1. X side, the x-axis indicates the study time and the y-axis indicates the performance of students. Then there is we can say according to this graph, there is a positive correlation. Why? When we increase the study time, students' perform also increase. But here, the x-axis indicates us the negative, study time. Y-axis indicates again I'm repeating. Y-axis, y-axis indicates the students' performance. But according to this graph, when the study time increase, when students increase their study time, their performance, they get low performance. That means there is no negative correlation. Opposite direction. Here, if we get a graph like this, then there is no correlation. We can't say anything about the time and student study time and here no correlation. Some perfect. So here see, this is the equation. Don't afraid of the equation. It's very simple thing we have to do. There are two ways where we calculate the correlation. Pearson correlation coefficient and spine. Let's see the first one, Pearson one. This is the equation. According to the equation, we have to substitute the values and we have to find. The finding value will be between plus or minus 1 to 0 to 1. Here, how this data, here it is explained, about the correlation, high positive correlation, or if this are according to this equation, here According to this equation, this R, it has a value. That value lies here. If it is the value between 0.1, 0.91 to 0.99, very high positive. Like that, the relationship you can read and understand. Here what is X? This is N means we know frequency or whatever the sample size we know. Now we know the sigma means summation, I mean total. X means here total of X and Y. X means the observed data for the independent variable. We will discard with the example. Here you can suppose here students, number of students. There are number of 20 students and their height is given here and their weight has given here, right? So, is there a relationship between height and weight? If height is, if the tallest students have the, or how can we say? If it is, there is a relationship, I mean, more weight than high weight. No. Yes. The students who have uh, high weight have, I mean, thin and short. I confused there. Thin and short, height and fat. Like this, is there a relationship? Oh, thin and high, short and fat. So we have to need these data. See, X and Y now here. There's all the here. What are the unknown, I mean, data? See, X and Y, the summation of these, all these things, this is N. Here, it although the equation is very big, I mean, complicated, here see we need only x, y, two variables and the number of sample and then we will get the R. Here see x and y. Here, according to this, we have to tabulate this table. This is x, this is y, x and y, x squared, y squared. Right? Like this, we have to find the answer. So here, summation of x, summation of y, summation of x and y, summation of x squared, summation of y squared. These are the values we need. Then we have to substitute here. Here, summation of n. N is, what is the value of n? 20. Here, 20. What is the value of summation of xy? Xy, sorry, other side, no? Xy 1.578. Sorry, not point. 1578. Here, 1000. What happened? That is why now I talk about y now. That's why I confused here. X and summation of x and y. 2000. I mean, here see this value. 289. Here is the big value. So 982 lakhs and 80,925. That is here. Then minus. Then we have to substitute this value. These two values. Then square root. Under that, we have to substitute 20 in x squared value minus value like this. Then you will get r is equals to 93. Just a simple calculation. Inferring to take time and study and try to understand. Do the sums. Referring to our table of qualitative interpretation of R, we can calculate that the highest and weights of 20 students in the sample are having a very high correlation, right? According to this, here what is the value? 0.93. Then here see 0.93, 0.93, 0.91, between here it is. Now plus value. Plus mean high position. Very high. Very high. Right? Plus or minus. Very high. The relationship is very high. Right? So if it fat and tall and fat, short and thin, positive. This way. High weight, height, like that. Okay. Then the Pearson and Pearman. Pearson correlation coefficient, how the relationship between two variables, it tells us. Now we going to the Spearman's rank correlation coefficient. Here also we are going to find the relationship, but using another formula. Right? There also the value lies between +1. There the value lies between +1 and -1. Let's see the Pearson, this value. There are the value of Spearman. P will always between 1 and -1 and plus. They are 0 and 1. This is the equation. If we get the value this one as like this, we can describe like if the value we get 80 points 0.83, then we can say very strong relationship is there. If we get an answer like that 3.3, 0.33, then there's a weak relationship here. This type of relationship, monotonic, non-monotonic. It's right. Here we have to find the values. This is the value. We have to rank them. That means the side. Let's say these are students. There are 15 students. What is that? Teacher should arrange the paired data in a table allowed to is analyzed. Can be spread. What is the side distant from the source rank, right? The which number is the highest number? Yeah, rank you have to, right? Rank here, side, distance, width, yeah. You have to fill the data here. Likewise, again, you have to fill the data here. Take a minute. fill the data. You see 1, 2, 3, 4, 5, 10. 1, 2, 3, 4. Here why we have a 11, after that 12.5. Why is that? The same value. Yeah, the same value. Yeah, R1 minus R2. R1 minus R2. Yeah, R1 minus R2, 0. Here also 1, here also 1, then 0. R2 minus 2. Here this is R1, this is R2. So you have to get the total. Then you have to substitute. Then you get a results like this. R is 0.974. That means value is in it indicates perfect negative correlation, and +1 indicates the value of between is generally seen as the being 2V. Yeah, but this is the, you see, it is 0.974. 0.974 lies between here. That means perfect positive correlation. Right? Here are some, examples. You can calculate that one. A, B's participants, students, rank according to the highest value, and you see 99 is the highest one. This is the lowest one. Then this is the score B. Then here also 1, 2, 3. Then why 2.25 here 1, 2, 2, 5? There are two numbers are same here. Here one has scored, E has scored 89. Here also G has scored 89. That means the second place and the third place. First, second, third. Here, fourth is here. So, second and third, the second 2 plus 3 divided by 2, then 2.5. Normally, how we rank our students in the report cards. First place, to second place, like that now we say. That's not third place, then fourth place. Like that here, 2.5. It's according to the here which sense we substitute. We do fill the table and we substitute the values. The answer is 0.63. Strong positive relationship. Reject hypothesis. What the hypothesis may be, there is no relationship. So we reject, because there's that means, let's say this is the maths marks and this is the science marks of A. We have to check whether the marks of students, science marks, is there is a relationship, connection between the science marks and maths marks. According to this, the answer, this is, 0.63 means strong positive relationship. Then how can we interpret, explain it? If a student, the, the student who perform better in science also perform better in maths. That's the relationship. The student set who perform lower in mathematical also perform in lower in science. Lower, lower, higher, higher. That is the, strong positive relationship we can find here. That's why we say like that. Right? So here, positive means both increase together. Study time and marks, for an example. Negative means one increases, other decreases. Absenteeism and marks. When students get absent to the school, they get lower marks. Zero means no relationship. Shoe size and exam marks. What a relationship. Shoe size and stuff. So these are the value. Correlation coefficient is strong, very strong positive, moderate positive, no correlation, moderate negative, very strong negative. Uses of, what's the use of correlation? We can, based on that, does class test predict exam performance well? So we can give the guidance. So according to that, counseling, program evaluation, we can select and place. One case we can use, example, if the correlation between school-based assessment, SBA, and GCE O-level results is high, SBA is meaningful. Nowadays, as teachers, you think in our schools we send SBA marks to the what ministry, examining department, SBA marks, O levels and A levels. And there is a relationship between the SBA marks we send, sent by the school, and the O level results or A level results. If there is a connection, if there is a correlation, then SBA is meaningful. Think whether in our curriculum, the way we use SBA nowadays, no, I'm not talking about the new reform, now what we practice and at A levels and O levels, can you? What do you say? Is it meaningful or meaningless? You think, then find the answer. It's up to you. As a teacher, you can. Significance, why chi-square? These are cost telling. Right. This is what, no, chi-square. We call this as chi-square. The relationship with Spearman and the Pearson. School type. Let's not work. Pass, fail. Gender performance, whether the gender performance are associated or not. For an example, studies, there is a relationship between gender and passing in mathematics. That's the question. That's the height. Then boys have passed. How many boys have passed? 60. How many girls have passed? 35. Altogether 65. How many girls have failed? Boys have 10. Girls 5. Then fail rate is 50. Total pass and fail 40. 40. 80. 40, 40. Pi helps determine whether gender and performance are associated or by the differences by chance, like that. Not to understand like that, right? Those are the things we learned today. So what we discussed so far: mean deviation, standard deviation, and how to find, calculate them for group data and ungroup data. Then we discuss about the normal curve and its characteristics. Normal curves, characteristics, and what does it tells us. Why we need a normal curve means what? You can explain that. We, after that, we relationship. To find the relationship between two variables, we use two, correlation coefficient test. One is Pearson test, so we have to use this equation. Again, we have the Spearman rank correlation test. There we have to use this equation. That's what we have discussed so far. So, if you have any doubts, you can clear in the other class. You can discuss them. So, I think now the time has come to wind out the session. So, thank you so much for your. Please try to understand and get a better. Again, I mentioned that you no need to get afraid of these equations. There is no need to memorize them. They will be given in the exam. So you don't worry. You have to just to substitute and get the results. That's all. Have a nice day.